Okay, it's go time. Hey, everyone. Thank you for being here. My name is Divya Wagner. I lead the technical services team in the Americas. And on behalf of Arista TAC, I'd like to extend a very warm welcome to all of you. Whether you are joining us here for the first time or you're returning after watching us in session 1, we're super glad to have you here because this entire webinar series is made possible by attendance and feedback from viewers like you. So we're happy to have you here. And, when we originally came up with the idea a few months ago of putting this session together, we weren't 100% sure what the feedback or the reception was going to be. But the fact that we've had a lot of great feedback come from session 1, a lot of great ideas of what you'd like to see. It's got the team energized and motivated, and already, we're looking forward to extending this into 2023. In 22, the September, October, and November series of webinars, it is based on establishing a baseline, right? We're covering some important things that you should know about the extensible operating system, including logging, important commands, health checks, upgrades. And what's unique about this webinar is that we're not just telling you, here it is, but it is chock full of information gained from, insights from the field. These are questions that we get on a daily basis from customers. These are cases that we get. And so, we thought this would be a really good way to be able to share this information with all of you. And hopefully you find this useful. And speaking of, putting these things together, the team's always very excited when we're looking at what information would be great to present to you. And so I'm going to forewarn you that while this session was originally meant for about an hour, it is likely to run over by a few minutes. So I would anticipate anywhere like 1 hour, 15 minutes. And the same will apply for the November session as well. It'll probably go over a little over an hour. It's a good problem to have because our engineers love to share insights and information with all of you. Now, if you do have a hot stop, that's okay. I mentioned earlier that this webinar is being recorded. So if you need to come back and watch it, if a team member or a colleague of yours was not able to make it, or if you feel like this would be useful for other members of your team at work, you are, more than welcome to either to have them register or to just watch the recording. The recording as well as the slides will be made available to all of our registrants at the end of this session. Now, since you are here, you do have the luxury of posting questions, and we have a panel of technical leads who will help answer those questions live. So if you have anything, just type it in and we'll be able to take care of it. I think I already see a question that's popped up there. So we'll get to you shortly. And with that, I want to, introduce our presenters for today, Devroy Peterson and Himanshu Singh. Today's session is going to focus on EOS upgrades, a topic that's very close to all of our hearts. And Devroy is going to talk you through how do you do this from the switch CLI, and then Himanshu is going to walk you through how to do the same thing if you are deploying Cloud Vision in your network. And the cool part about this series, it is brought to you by TAC. And so the guys that you are seeing presenting could very well be the same people that you speak to when you give us a call. And we thought this would be a great idea, not only to share information, but to create those relationships. And if you're new to Arista, hopefully this helps give you exposure to what the Arista TAC team is like. And with that, I would like to hand it off to Devroy to take it away. Devroy, over to you.
Thank you, Divya. Hey, everyone. My name's Devroy. I've been in the industry for about 10 years, with my last 2 years being here at Arista. And I kick off our webinar today with an explanation of EOS. As Divya said, EOS stands for the Extensible Operating System. That naming stems from how we've approached that operating system architecture. We started with a strong foundation of pure Linux, and a lot of vendors use Linux underneath the hood. We do things a little bit more unique. We actually don't modify our kernel at all. We keep all of our code in user space processes. The benefit of this is it allows you to put any application on the switch that you want without it needing to be ported to be in a non-standard environment. So we have access to standard open source tools like our text parsers, TCP dump, Python and Go, for example. On top of that, we're using a state sharing architecture. Our CTO, Ken Duda, has a really good YouTube video about this called Arista EOS, a tale of opposite architectures. I think it's like a half-hour long. It goes into a lot of great detail about how this works under the hood. The long and short of it, though, is that we've improved our overhead with internal messaging, so our agents or processes can restart with minimal impact on the rest of the system. We've taken that and bundled it into a single binary that can run across the majority of our switching platforms. So if you have a data center switch, a campus switch, or even some of our ultra low latency 7130 platforms, they can all run with the same binary image. And that makes it very streamlined and easy to manage software for your platforms, especially if you have something like CloudVision. So even though we offer a single binary for the majority of platforms, you will occasionally see a couple flavors of that binary. The standard image is going to follow this format. You'll see EOS, followed by 3 numbers, followed by F or M.SWI. The first 2 numbers here are going to be the train. The third number is going to be the release in that train. F indicates it's a feature release, meaning we're adding features to that software train. M says if it's a maintenance release, meaning it was created to fix defects in that software train. So if we have this software, for example, 4.27.6M, we know that's the 4.27 train running the .6 release, and then it's a maintenance release. You might see these other flavors of EOS if you look at our download page. We have a 2 GB version, which is meant for older platforms with a smaller flash memory. And a lot more common now, we have our 64-bit image. We've added that in 4.22, and it's become a lot more popular with time. And the majority of our current platforms do support 64-bit images. I would honestly expect this to be the recommended EOS in the future, just because of how much more capable 64-bit EOS is. Moving into the virtual realm, we kind of have 2 pairs or 2 sets of virtual images. First, we have our lab images. You'll see our VEOS and CEOS. Since they're lab images, they're layer 2 only with very limited feature sets and very low throughput. But you'll see we have a VM and container packaging. For the actual production use, we have CloudEOS router, and you'll again see we have a container and a VM packaging. The VM is going to be a little more high throughput. It's going to have IPsec and control plane, just because it's a VM, right? Because the VMs virtualize the entire machine down to the hardware layers, and the containers are just for the software layers above the operating system layer. But now that you kind of understand what the different images are, where do we go to download those? If you go to our Arista software download page, well, you'll see a lot more than what you see here. I've snipped it to kind of fit on our slide, the part that we care about. You'll see this folder hierarchy with a lot of information in it. I've broken it up for an example where we might be looking for 4.27.6M. You'll see we go to the active releases, which has all of our active trains in it. We're going to go to the 4.27 train and then open up the 4.27.6M image bundle. In here, we have a lot of different files and folders. First, we have our lab images. Beyond that, you'll see our standard image and our checksum files. So the checksums are actually human readable files. You'd want to download it and open to verify when you download a software image that the checksum is correct. Beyond that, we have our 64-bit image and checksum file. And then if you want to use CloudEOS, you'll see it's not in the normal EOS folder. We have a separate folder for CloudEOS. You might see VEOS router. That's our kind of old naming for it. Everything's been moved to CloudEOS. And then we have CloudVision as well, which Himanshu will get into later. So I said active release. What does that mean? Here I'm talking about trains that are still inside their life cycle. Our EOS follows a 3-year life cycle that we split into 3 phases. First, you'll see we have our new feature development phase, and that's where we're releasing our F images. These are where we're adding as many features as we can safely in the first couple versions of code for that train. Once we've added all the features we want to add to that train, we move it to a maintenance phase. We're not adding any new features at this point. We're simply releasing software that includes bug fixes. That'll go on for 30 months total, or 2.5 years, after which we go into the support only phase. During this phase, TAC is going to be glad to help you, but if you hit a new defect, it's not going to get fixed in that software train. You have to upgrade to whatever the latest software train is. If you go to our EOS lifecycle page, it has this picture and it has a lot more information than what I provided here. One of the cool things it has is this chart that shows the current trains and the phase they're in and end of support. So I'm talking about 4.27. We see it's currently in its maintenance phase with end of support being in September of 2024. So with all that image talk complete, let's talk about actually how do you upgrade the switch. We have our standard reload upgrade. This is what most people would be familiar with, where you would set your boot statement to point to the new version of code and then reload the switch. Everything goes down, and then a few minutes later, it comes back up running the new image version of code. But because of how we've implemented our operating system, we actually have something a bit better than that. We have something called the Smart System Upgrade. What we do here is we optimize the boot sequence, and we actually don't bring down the data plane while the control plane reloads. So we can forward traffic in hardware while the switch reboots. And so we end up seeing less than 1 second of data plane downtime. There are limitations with this as far as which hardware and software and feature sets are supported with that, but we'll talk about that a little bit later. We also have the in-service software upgrade, or ISSU. This is meant for MLAGs, and it allows you to basically upgrade the MLAG peers one at a time, so you don't have traffic disruption. We'll be talking about this in webinar 3, which is going to be MLAGs and modular systems. So I'm not going to go into much detail here. But I do want to dive into more technical depth about what's going on with our upgrades to make you maybe understand more why the Smart System Upgrade is a lot better than the standard upgrade. So with the standard upgrade, you enter the reload command, and immediately you're going to see your control plane goes offline, your data plane goes offline. As it powers back on, our bootloader, a boot, is going to look for our boot config file. That's going to include our kernel and root file system, basically the information that tells the switch to act like a switch. After that, we do something a lot of people don't realize we do. We actually will detect the target image we're upgrading to and copy it to a hidden file on flash. The goal there is basically it's a safety mechanism to protect users from scenarios where the image is accidentally deleted off the switch and you don't have usable version of code on the switch. And I'll show you actually that file in our demo later. Then we go into our kernel and init phase. This allows us to self-identify the hardware. Because we use the same binary for all those different platforms, this is a stage that says, hey, what hardware am I running? And it will use that product-specific information to figure out which programs need to launch. Basically, the first program that's always going to launch, regardless of the platform, is going to be sysdb. So this works with our other core components to determine which agents or processes need to be ran and in which order to bring them up. And part of this process is our forwarding agent coming online in our switch chip initialization, which means we have our forwarding tables, but they need to be initialized to a 0 value, just so the rest of the applications have initial value to work with. Then after all that happens, the system's up and ready to forward. If we compare that to our Smart System Upgrade, though, one of the first things you'll notice is our detecting and copying of the new image occurs before the control plane reboots. And that makes sense, right? We don't need the control plane to be down while we're changing and copying an image over. Once the switch goes down and comes back online, you'll see we also skip this BIOS step. And we just do something clever there where we boot from one kernel directly into a new kernel so we can skip this phase. And this is where I think the cool stuff happens. You know, we still have our sysdb state. We have something called fast packet restore. What it does is our hardware will actually generate control plane traffics on behalf of the control plane. So for example, the hardware will generate BGP hellos and LACP keep alives. So our neighbor ships don't go down even while the control plane is offline. sysdb actually does a few things different here too. It'll prioritize agents that will be responsible for our continued forwarding. So for example, we'll bring up our routing protocol agents and our programming agents before something like our command line or our temperature agents. So it just decreases the control plane offline time. And then we don't do a switch chip reset here either. We maintain the programming, and once our agent's online for programming, it'll reprogram that table in case any of the programming changed during the reboot. And that's where you'll see that 1 second downtime. Really, I've only ever seen it be 100 to 200 milliseconds. I guess theoretically, if you had really big tables, it could be a second. So now that we understand the boot sequence, let's look at the upgrade sequence. So the steps we want to follow for an actual upgrade. Now you'll see our smart system upgrade is mostly the same with two big differences here. One, we have a command that lets you check your smart system upgrade compatibility. And then second, the actual command to reload is different. But let's start with the standard upgrade, and then we'll do a demonstration of that, and then we'll talk about the differences here. So standard upgrade, and same with our smart system upgrade, we always want to have pre-upgrade checks. It's going to be dependent on your environment and your company policies. In general, this is what I see used successfully. Having key performance indicators, KPIs. So you should know and be able to monitor the critical devices in your network to make sure they're reachable, and if possible, have network performance information. So during the upgrade, you can keep an eye on that. And if you're not supposed to lose access to one of those, if it does happen. Having a backup plan, so if the upgrade does go poorly, you have a plan in time to downgrade or take whatever steps you wanted to take at that time. Doing this during an upgrade window. So even if this is hitless, we still recommend having a maintenance window, just because, I'm in TAC, I've seen everything possible that can go weird or unusual. So we definitely recommend having a maintenance window just in case. Then if possible, you can offload traffic from the device. This would be something like BGP maintenance mode if you're using BGP, or if you have the capability, you could be shutting down interfaces to physically force traffic away from the device during the upgrade. From a switch perspective though, generally I recommend backing up your configuration. So you do a write memory, obviously, to copy your running configuration to your startup. You might want to copy that to a separate file on flash in case something happens with the startup config. Really though, I'd recommend backing this up off the switch. So if the switch does have a failure, you have a copy of the configuration somewhere. Making sure your current EOS is on the switch. You don't want to be in a scenario where maybe your new image, your target image, was corrupted and you try to boot it and that fails to boot and you don't have an EOS to back off to. So you want to have your current EOS on the switch just in case. And then make sure there's enough space on flash for the new image. And we generally recommend making sure there's at least another 240 megabytes of free space to log diagnostics if there's a boot failure. Once you know there's enough space on the flash, you want to copy the image to the flash. Again, typically that's the flash. I have seen some people use USB, but that's pretty rare. As far as copy commands or mechanisms go, from the CLI, we have a lot of different copy options. I put a couple common ones here. You can also drop into bash and kind of get crazy with it. For automation, I've seen us use curl a lot. The important part of copying the image, though, isn't how you do it, but making sure it's done correctly. So we definitely recommend using this verify command to make sure the MD5 checksum of the image matches the MD5 sum of what we say it should be. And that's that MD5 sum text file on the software download page that we talked about. So with the image physically on the switch, we want to update our boot statement to point to that. So again, we use a boot config file to locate that EOS image, and it has some other information in there as well as far as initial configuration settings. You update the boot config file with a standard boot system command to tell it to point to the new image. To make sure that took correctly, you actually can use a show boot config command. And I grew up for software, there's a lot of output you'll see in our demonstration. And just make sure this points to the right image. One thing here people don't realize too is when you update the boot config file, you don't need to write memory for the reload to do the upgrade. Technically, in the running configuration, you'll have a comment that says what the current boot statement is, but there's no actual command in the running config that tells it what version code to run. It's all on this boot config file. So we set the boot statement. Now we need to perform the reload. You can reload at a specified time and date or in a specified amount of hours and minutes. I don't see that very often. If you do that though, we also have this reload cancel command. It lets you cancel either of those reloads. We have reload force or reload now. The goal of that is that it'll reload without any prompts, which would be used for like automation where you don't want your scripts to have to account for different prompts that might come up during the reload. We have a reload fast boot that does the smart system upgrade. And then we just have the reload with the carriage return that reloads with the prompts. Now the prompts you're going to see are generally going to be one of two things. This is kind of a standard prompt. It means everything's good. Let's reload and just confirm it. You might also see this one. It says your system configuration has been modified. What that's telling you is your running configuration and your setup configuration don't match. So it gives you the options to save the configuration and reload. Don't save the configuration and reload. You can cancel the reload command altogether. Or something I like a lot, it's really cool. We have this diff command. And diff will show you the differences in your configurations. So if you run the diff command like I have in my example here, if you have plus, it means it's in the running configuration, but not the startup. Minus is the opposite. It means it's in the startup, but not the running. So in my example here, I have a plus next to my no switch port. So in my configuration, my running configuration, I had this, but not my startup. So it's just useful for identifying that difference before you decide if you want to save or not. Once the upgrade completes, we have these general post-reload checks. The main thing for me has always been check your KPIs, your key performance indicators. Again, if you have critical systems that you're monitoring, you want to make sure they're still reachable and accessible. And the same with your general network health. On the switch, the first thing I always check is show version, just to make sure the upgrade went correctly. If that's wrong, then I know something went wrong in the actual upgrade process. You want to confirm the interfaces come online. And with a standard reload, because we do that switch chip reset and our initialization, that can take a few minutes. So if you log in immediately and your interfaces aren't up yet, give it 5 minutes and then they should be online. Once your layer 1 is up, you want to confirm layer 2, your spanning tree, your lags for LACP, anything you're running layer 2. And then check your layer 3, make sure OSPF, BGP, all come back online and reconverge correctly. And then once all that's good, I'll go back and check our logs. Just do a show log and see if there's any errors or failures that get logged during the actual boot up process. So let's go through a quick demo where I do an upgrade in the lab. And I've recorded this just to speed it up a bit and make your guys' life a little bit easier. So this is my lab environment. I don't do the normal pre-upgrade steps that I just advertised. What I do in the lab is I'll generally have console access so I can watch the switch boot myself and make sure it works correctly. I'll do pings to the switch just so when it comes back online, I see pings start to complete. I know I can probably SSH into it. And then since it's our lab, I always have somebody on site too. So if something really goes sideways, I have somebody on site who can figure out what happened. So for this upgrade, the first thing I always check, what platform am I running? I'm a 7050 TX3 running 4.27.6M. Oh, give me a second. I'll restart. Sorry about that. That's not the image I ought to be running. Let's check that one more time. All right. So I check again, the magic of video software. I'm a 7050 TX running 4.27.4M with a goal to upgrade to 4.27.6M. And a spoiler alert, I guess it works. The first thing I do is write memory. I want to copy my running config to the startup. And like I talked about, I also want to copy this onto Flash somewhere. This is the naming scheme I like to use for those files. I'll do the host name. In this case, a little bit confusing because my host name is switch. I'll say it's config, and then I'll put the date. Just so if I do copy it or touch it and the timestamps on the file itself change, the file name tells me when it was created. And then I'm going to copy this to another location. Generally, you want like a file repository for all this. And you'll see I'm doing copy to SCP or with SCP from the CLI. Now I want to check to make sure my current version of code is on the switch. So I check it here. Yep, 4.27.4M is here. I see a decent amount of Flash utilization, but I don't think it'll hurt anything. So now I'm going to just download the file from my repository, I'm using SCP again, but you'll see I'm using bash. Now this is more common for what I'll do. I'm just more familiar and comfortable with using bash to run a lot of these commands. But like I showed before, you have a lot of options for doing that. And once I start this, I fast forward a bit just so you're not waiting for a few minutes, listening to me ramble while we download the software. All right, says it downloaded. Let's verify it hasn't been corrupted. So we'll do our verify MD5 command with that target image. And one thing I did do here to make it more clear, that MD5 sum file from the software download page for this image, I copied to my switch ahead of time, just so you guys can see I'm comparing the MD5s of the two. So run our cat. Okay, looks the same to me. So at this point, we're ready to set the boot statement. So boot system, and then the target image on flash. One thing I note here is because we are setting a boot config file, we're updating the boot config file, not just updating our running config. Sometimes it takes 5 seconds to happen. If you see that, it's not breaking anything. It just takes a minute to open the file and modify it and save it. We're on show boot config to make sure the boot config file is updated. The top line we see here, software image does point to the new version of code. So that's great. Let's start the reload. Now I am reloading from console just to make it more clear that the reload's occurring. You'll see a lot of cryptic output on reloads and on boots. Generally, it can be ignored unless the boot or the upgrade actually fails, in which case we'd look more in depth at that. But you'll see a lot of things that look scary but mean nothing. But we'll see here, we got through the reload. We've initialized. We're going to log in as admin. And we'll double check our show version to make sure we booted into the right version of code. Like you saw before, 4.27.6m, the upgrade was successful. All right, so let's talk a little bit about the smart system upgrade, and then we'll do a demonstration of that. So the first step we generally run for the smart system upgrade is our compatibility check, which is our show reload fast boot command. And this just checks to make sure everything on the switch actually supports the smart system upgrade. One thing it doesn't check for is free space, which can be an issue. If you try to do the upgrade without the free space, it'll just back out of the upgrade. It won't do anything. There'll be no impact, but it will tell you if you don't have enough free space once you try to do that. The most common things I see here are that you need BGP graceful restart and OSPF graceful restart set, just so we can maintain those control plane connections while the control plane actually goes down. There are several known unsupported configurations, though that list is decreasing over time. For example, 4.27, we added PIM support for SSU. So if you have PIM, NSF, nonstop forwarding, you can do an SSU still. We have this really good article one of our SEs wrote that goes into details about the smart system upgrade and which platforms are supported. I would read that if you have questions, or beyond that, definitely feel free to reach out to TAC or your Arista systems engineer. We're always glad to field those kind of questions and help you understand, will the smart system upgrade work with your configurations and support you through that process. Now, I said that the show reload fast boot command doesn't check to make sure there's enough space on flash. The reason that's an issue is that we actually have 2 versions of hidden files for the version on your flash. So we talked about earlier, we copy your running software to a hidden file on flash. When we do the smart system upgrade, we do that with your destination image as well. It takes up more space, but it significantly decreases how long the control plane is down because of how we manipulate those files. But because of that, you have to make sure there's enough room on flash for 2 times the new image size. And of course, we still recommend that 240 megabytes of free space. You'll see this in our smart system upgrade demo, which is right here, though. Let me pull this up. So this is going to be the same switch we were just on, but I did keep our software, the 4.27.6M on flash, just to cut out that step. So 7050 TX3 running 4.27.4M. First thing I check is our show reload fastboot. And like I said, BGP and OSPF without graceful restart, super common reasons to have it kick an error here or a warning. Big caveat with graceful restart on BGP is it will restart your BGP connections because BGP has to negotiate graceful restart. Don't configure these without knowing what the impact could be and making sure it makes sense for your environment. Again, I'm a lab environment, so I can get away with it, but make sure you check that yourself. We write memory, we check our show reload fastboot, and it looks fine. No flagged errors. We'll update our boot statement to point to the new image, 4.27.6M. We'll give that a few seconds to actually update the boot config file. And once that finishes, we'll do show boot config and scroll way up to the top again to see the software image points to the new version of code, 4.27.6M. Looks great. So we're ready to start our reload fastboot. And like the other reload, you're going to see some cryptic information in here. You don't have to worry about it. Like this is just about our internal versioning and hey, this is a Strata platform. But this matters. It says we don't have enough free space on our flash. What's up with that? So do DIR. Let me check our free space. Yeah, we don't have very much free space. Scroll up. We do have some big files, literally taking up a lot of space. You can use DIR to find those files. I like bash again, so I'll use the find command. And I'll tell it to only show me files in the flash greater than 100 megs. And I'll have it show me the size of those files as well. All right, we see some big files. Oh, this is our hidden image for the current EOS. You'll see it's just a file on flash .boot image. I'm going to pipe this to an RM, so I actually don't want to include that file here. So I'm going to do a not name, and this is going to be regex. So anything that begins with dot, I don't want to include here. So remove that. I also don't want to delete our current EOS or our target EOS. So I'm going to actually use grep this time to say, hey, don't include these two files. And then I'm going to pass that to xargs rm. So delete the other files. Now, just in case I double check LS, I want to make sure my current EOS and target EOS are still here. And they are, so that's good. Now let's check DIR, make sure we have lots of free space. Oh, tons and tons of free space now. So let's go ahead and move forward with the reload fastboot. Once again, I'm going to do a fast forward. It's hard to compare because I'm fast forwarding everything, but the control plane downtime is a bit less here. Now, you might ask about this completing EOS initialization, escape to skip. It doesn't make a difference. You get the login prompt quicker, but your AAA agent is running, so you can't log in. All right, we're logged in. We check show version 4.27.6M. Okay, upgrade is successful. So with that demo out of the way, let's talk about some of the common questions we get with, well, basically everything I just talked about. The most common question we get is about EOS recommendations. You know, hey, what EOS should I upgrade to? Which one should I be running? TAC itself, we don't recommend specific images because that requires a knowledge of your environment that we don't have. And that's where we generally redirect that to the account team because they'll know, hey, 4.27. Whatever has a PTP defect, but you're not running PTP, so it's fine. Or, hey, it does have a defect and you are running PTP. We don't want to run this version of code. So they can use that knowledge and their prior experience to know what's going to be best for your environment. In general, we have a recommendation of just being basically on the latest maintenance release. Just so that's going to have the most bug fixes out of all the other releases. If you have older hardware, you know, what is the latest EOS image supported? Because at some point we do a cutoff, right? Our real old initial hardware we ever developed can't run the latest software. If you want to check if your hardware supports a specific software, we go to this end support page and it'll tell you, for example, this platform no longer has software support beginning in 4.27. So you know you have to run an older software than 4.27. And then, hey, is this image still supported by TAC? Is it going to have bug fixes? I'll answer the question, of course, but I also redirect to the product lifecycle documentation that says, yeah, you're in a maintenance phase, here's under support, here's how these different things work. Now, besides those general questions, actual issues that customers see with the upgrades or reloads, most common would be we reloaded and the switch didn't come back. And what we recommend in those scenarios is get a console connection and see what's going on. Generally, you'll see you're in this a boot shell. Again, that's our bootloader. This will happen if people forget to check the checksum of the file and it accidentally got corrupted during download. So when they try to boot it, the system says, this is a corrupted file. I can't boot what you're trying to tell me to boot. So it falls back to this a boot shell. We have an article that goes over all the different reasons this would happen. There's like 2 or 3, and then ways to recover from it, whether it's going to be updating your boot statement from a boot or modifying your image in Flash. You can do all that from a boot. One thing you might also see is this, no startup configuration found. And that is problematic because if you don't have a startup configuration, your switch boots into what's called a zero-touch provisioning mode. What that means is when the switch comes online, it'll reach out to the DHCP server, a DHCP server, any, to request an IP address, but also request a boot file URL. If the DHCP server does not give it that file, it will wait a few minutes and then reload and try again. The goal of that is supposed to be for something like an actual ZTP or zero-touch provisioning environment with CVP, for example. But if you're seeing that, it means you don't have a startup configuration, and you can cancel that process using this zero-touch cancel command at the CLI. And this is kind of the most unique or odd thing customers will see. It kind of threw me off the first time I saw it too. You'll upgrade your software and then you'll log into the switch and you just don't see parts of the switch showing up. You might not see any ports. Hey, we only have 1 port. And it's a management port. We don't see the other 48 ports, or show inventory shows nothing. Show version says not available. What this means is you've upgraded to a software that doesn't support that hardware. For example, we talked about if you had older hardware where the new software is not supported, what happens is in that init sequence, it checks for that product specific information. And if it doesn't find that product in its own like internal code base, it'll try to boot the best as it can, but it can't properly interact with hardware. So it can't bring that stuff online. It can't even really identify what hardware it's on. Most time it'll still bring up the management port, so you still have basic access. But you will see this happen when you have older hardware trying to run new software, or if you have new hardware trying to run old software. And that makes sense, right? If you have old software, it can't know about newer hardware. All right, with all that said, I'm going to hand this off to Himanshu now, who's going to drive this from the CloudVision perspective.
Hey, thank you so much, Deborah. So let me just start my screen share. All right. So hello, everyone. My name is Himanshu. I've been with Arista TAC for 5 years now. So in the second half of this webinar, we are going to switch gears and where we'll be taking a look at how do we upgrade the EOS version on our Arista devices using Arista CloudVision portal. Now, before we jump into the details, a quick introduction about CloudVision to folks who are not familiar with the terminology. CloudVision is a turnkey solution for our network-wide workload orchestration and workflow automation. So as CloudVision product, we have a network-wide visibility to all of our switches in your deployment, whereby using the event-driven telemetry streaming analytics platform, you have the live state of all the switches currently streamed to your CloudVision instance. You also have your network provisioning modules, which allow you for configuration and image management. Now, as part of this webinar, we'll be focusing on the image management module, which allows you to do a lot of things, including maintaining an image repository on CloudVision itself. So you can upload EOS images to the CloudVision portal instance where you can maintain multiple images at the same time and decide which images you want to upgrade to for a particular fleet of devices. Now, you also have the ability to validate images. So validation is also done by CloudVision portal to ensure the EOS image that is getting uploaded is supported by the CloudVision portal in order to ensure there are not any compatibility issues. Now, you can manage EOS image for a single device, or you can also do that for a group of devices. So for example, if you have a fleet of multiple leaf switches that you want to upgrade at the same time, you can do that. Or if you want to perform an MLAG ISSU upgrade, that can also be done using CloudVision Portal. Now, a very good feature as part of CloudVision Portal is CloudVision checks if your EOS image is already present on the flash drive. So for example, as Devroy showed you, that we had to copy the EOS.spy file to the MNT flash directory. Now, if you're performing this upgrade via CloudVision ensures to check if the EOS file is already present on the flash drive. So in case if the file is already present, we do not download it again, thereby reducing the network cost and also the time performed during the image upgrade. Now, another good feature wherein CloudVision makes our lives a lot more easier is allowing us to install extensions or fix files very easily. So for example, if you're trying to use Splunk or a Docker extension, anything that you want to install additionally in terms of functionality that you want to utilize, it is very easy to install any extension as part of CloudVision Portal. And also the upgrade of extensions, for example, if you want to upgrade an extension from an older version to a newer version, that is also possible without even having to reboot the device or affecting the EOS release, which is running on the switch. Now, where this functionality comes in a lot more visible or is much more useful is in terms of security patch installation. So let's say if you have a security advisory for which Arista has provided you with a patch, you can download that patch, upload it to CloudVision Portal, and push it across multiple devices in your network, thereby ensuring your Arista devices are not exposed to that particular security vulnerability. So that is also another good feature of CloudVision in managing your security patch installation on the devices. Now, before we jump into the core demo itself, I'd like to clarify a few key terminologies just to make sure that folks who are not familiar with CloudVision Portal are able to follow along as we go along with the demo, because some of these key terminologies we are going to be using frequently. Now, the first one is called an image bundle. So an image bundle is a key component in the image management when you're using CloudVision for EOS upgrades. It's nothing but a collection of the EOS file. So as you can see here in the image, I have an EOS file in an image bundle. And you can have an optional extension that you want to install on the switch. In this case, this is the Terminator, which is the streaming agent version that I want to install. It could be anything, for example, an HTTP daemon, or it could be an RPM that you want to install on the switch based on your needs. Then we have something called as containers. So think of it containers as a logical grouping of devices. So for example, you would have multiple leaf devices in your network, and maybe some of the leaf devices are in MLAG. Now, those devices are by default would share certain configurations. For example, they would share the MLAG configuration with a few differences, or they could share the virtual MAC address and things like that. Now, instead of managing these devices individually, meaning instead of individually pushing the configuration or the image to these devices, you can group them under a logical entity called as a container, and then whatever is applied on the container level is automatically inherited by both of these devices. Again, it'll be much more clear once we go into the demo. This is just to inform you beforehand that what containers mean before we start the demo itself. Now, there is something called as a task. So just like on CLI, you would do something, do an operation. So for example, you would edit the boot config file, or if you would execute the reload command. Similarly, all operations or all actions which are done from CVP are done using tasks. So for example, if you are pushing down a configuration, or if you are upgrading the EOS image of an Arista switch, all these actions are done as part of a task. So tasks are nothing but work orders using which you can take certain actions against the switch. Lastly, we have something called as a change control. So change control is a very nice feature of CloudVision Portal, which basically allows you to do a lot of things with tasks. So for example, if I have a task which is I'm upgrading the EOS image on 2 leaf devices. Now, instead of executing the task one by one sequentially, what I can do is I can group these 2 tasks under a single change control and run them in parallel. Thereby, I'm saving a lot of time, and also my upgrade gets done in one go itself. Now, that's just one of the features of Cloud Change Control. You can also add snapshots. You can also have custom actions using which you can build your pre and post checks, which again, we'll see in the demo itself. It also gives you a very good accountability in terms of we have all the actions which are logged, what all changes are being done, and it gives you a logging capability as well. So if you're performing an upgrade, if anything bad happens, we have logs in order for you to troubleshoot what went wrong during an upgrade using CloudVision. All right. So similar to what Devroy had showed you while performing the pre-upgrade checks on the CLI itself, we have something similar on CloudVision itself, wherein instead of using the show commands and directly running them on this EOS CLI, we are going to be using something called as built-in or customized actions and snapshots. Now, snapshot was briefly covered in webinar 1. What these are is just basically a cron job that you can configure on CVP. It's similar to a cron job where you can tell CVP to run a show command on the switch, capture the output, and store it. So I can tell CVP that, hey, just log into all my leaf devices, run the show MLAG detail or show version output, and capture the state and store it on the CVP itself so that I can do historical comparison, maybe before and after an upgrade, or before and after a configuration push is done. And actions can be any script that you want to create. It could be something as basic as checking the interface status. So for example, if you have a leaf device where you have critical hosts which are connected to a particular interface, maybe your MLAG port channel, or your uplinks which are going to the spine. And if you want to make sure that these interfaces are up before and after the upgrade, you can add this action to your change control where it will check if the interface status is up or not. And it could be something similar to entering the device into BGP maintenance mode and bringing it out of a maintenance mode before and after an upgrade. So these are the things that you can do as part of actions using the Cloud Vision. Now, we have very good content which has been written by our colleagues and available on our Community Central. So you can later go ahead and take a look at these articles which have detailed step-by-step instructions. How do you create change control templates, or how you can create actions? We also have very good examples on our public GitHub repository of these action scripts. Some of them you can use right away. For example, checking interface status, it is available on our GitHub repo, or also creating or collecting a TAC bundle before and after an upgrade. Now, with that said, let's go ahead into the core of the demonstration itself. So what I've done is I have created 2 demonstrations for you. In demo number 1, we are going to be seeing an example of upgrading the EOS and an extension. So the extension being the Terminator version, which is running on the switch. And we'll be building this entire change control, including the pre-checks and the post-checks manually. And in the demo number 2, it's just going to be an extension upgrade, just to showcase you how can I upgrade an extension without affecting the EOS image or without rebooting the device. The other thing that we are going to be seeing in demo number 2 is, okay, all right, I have created this pre-checks and post-checks, but do I have to keep creating them every time I have to upgrade? Now, in a network, the upgrades are not that frequent. Having said that, every time creating the pre-checks and post-checks can be a very cumbersome process and a time-consuming process. So in Cloud Vision, you have these features of creating a template where you can create a pre-check and a post-check template that you can apply to your standard upgrade process. Every time you just want to upgrade, you just apply that template and you're good to go. Now, with that said, let's switch over to the demo number 1. Now, what I've done is I've pre-recorded this session so that in few places we have fast forwarded it, because in some cases the EOS upgrade can take some time. So for this demo, I have set up a Cloud Vision portal instance in my lab and registered few devices to it. So let's go ahead and log into that. All right. So on the welcome page, you will be able to see all the devices which are currently streaming to this Cloud Vision instance. In this case, I have around 5 devices. I have my 3 leaf switches and 1 spine device. For the purpose of this demo, we are going to be focusing on the spine switch, which is a 7280 switch, currently running 425.3M, and the streaming agent version or the Terminator version is 119.4. Now, if you click on the device itself, this is where the telemetry information, which is actively streamed from the device, is presented to you, where you can see all the information about the device, including the uptime, the IP address, and the streaming agent version, which is 119.4. So in this demo, we are going to be upgrading this device, which is from 425.3M to the latest maintenance release at the time of this recording, which was, I think, 425.9M. And Terminator version, we'll upgrade from 119.4 to 119.5. Now, similar to what Devroy had showed you, we do need the EOS.swy file and the Terminator file in order to upgrade this. Where you can get this is go to our website, www.arista.com, head over to the support tab, go down to software downloads and select the EOS tab. Now, if you come down, you will be able to see the EOS folder. You can expand that, head over to the active releases, where you can see all the active release strains that are currently supported by us. We are interested in the 425 release strain, so we are going to expand that. And we can see we are right now on 425.3M, and we are going to be making a big jump to 425.9M. So we'll expand this folder, and we would download this file, EOS 425.9m.swy file. All right, so till here, it was pretty simple of what we had seen in the previous demonstrations. The only difference starts coming here. So since we are also going to be upgrading the Terminator version or the streaming telemetry agent version, we would need the upgrade file for that as well, that you can get under the CloudVision folder. So you can see we have 119.4 and we are going to 119.5. So we'll go ahead and download this .swix file. Now, once these files are downloaded to our local system, we can upload them to CloudVision portal to the CloudVision image repository. Now, in the future releases of CVP, we will have this functionality to directly download these images from our website over to your CloudVision instance. So you don't have to spend the extra cycles of downloading it to your local system and then uploading it. It is currently available as a beta feature also. So if you have a CloudVision instance available with you, you can test it out. So let's head over to the UI. We'll head over to the provisioning page, which is where all the network provisioning operations are managed. So any configuration management or the image management is done from this provisioning page. And at the welcome, it looks something like this. It'll show you all the devices which are currently registered. You also have default containers which are created for you. One is the tenant container, which is the root of everything. And then you have an undefined container. Now, the undefined container is a container where all the devices by default go to when they are first onboarded onto CVP. So let's say you onboarded your device for the first time onto CVP, it'll go under the undefined container. If you want to create a new container, you can just right-click, add container, provide a container name and hit on OK, and that will create a container for you. Now, for the purpose of this demo, I've already created a container hierarchy where I have a DC1 fabric. Under that, I have DC1 leaves, which contain DC1 leaf 1, housing my Arista 1 and Arista 2 switch, and DC1 leaf 2, which houses my VTIP 2. I have DC1 spines, which contains my spine device. Now, if you're comfortable with using this view, you can stick to this. Otherwise, you can change the view to a topology view, which will look something like this. Now, please do note that this is not the view of the actual physical network topology. This is just a view of how you have built your container hierarchy. So for the example, I have DC1 fabric, whose children are DC1 leaves and DC1 leaf 1, DC1 leaf 2, and DC1 leaves children are Arista 1, Arista 2, and VTIP 2 similarly. So this is not the actual physical topology, but again, we'll take a look at that in the later sections of this demo. For image management, we'll head over to the image repository tab. This is where we'll be able to upload and manage our image bundles, which we had discussed previously. So you can see I already have few image bundles which are uploaded here. Since we are going to create a new one, we'll just go ahead and click on create image bundle. That will give us this page from where I can upload my EOS.SWI file and Terminator file to CloudVision portal image repository. So you can click on upload and select the EOS file and select open. That will upload your file to CloudVision. Now, for the purpose of this demo, I have already uploaded the EOS file since it can take some time. So I'll just search the CloudVision image repository and I can see my EOS 425.9m is already present. So I'll just select that and click on add. Now this adds my EOS file to my image bundle. Now I also need the Terminator file. So I'll just go ahead and select, check if that file is also already present. I'll just search for 1.19 and I can see there is one file, but it's 119.4, whereas I need 119.5. So I'll go ahead and upload that file to CloudVision. All right, so now we can see our file has been uploaded successfully. We have our EOS file, we have our Terminator file, and we also have something called as a reboot required checkbox. Now, just a brief intro about this reboot required. This simply tells CVP if a reboot is required for that installation of whatever component that you're selecting it against. Now, by default, for an EOS image, a reboot is required. So that option is grayed out. It is not toggled by the user. But for an extension, you can select whether or not you want to reboot the device for the installation of that particular extension. Now, specifically for Terminator, that is the streaming agent, you do not need a reboot. That's why we'll leave that unchecked. Now our image bundle has been created. We'll just go ahead and give it a name so that it is easily identifiable without having to open the image bundle itself. So we'll name something like EOS 425.9m and TA 119.5. You also have an option of clicking the certify, which is just a cosmetic thing. It adds a star next to your image bundle. So once we hit on save, we can see our image bundle has been created. Since we have just created it, it's not applied to any containers or devices. So even if you open that, you can see number of containers and number of device count is 0. So you can also see that from the applied containers and applied devices tab. Now, for the image bundle assignment itself, you also have an option of adding a small node to the image bundle. So let's say if you're using the image bundle only for testing purpose, or if it is actually for deploying to the production devices, you can appropriately add a node. All right, so now with our image bundle created, we'll head over to the network provisioning page, from where we can either assign the image bundle at the device level, that is at the spine switch, or at the container level. To do that, you just do a right click, manage, and then image bundle. You can select your image bundle from here and then click on update. Similarly, you can do that same operation from the spine device level. You can do manage, image bundle, and select the image bundle and click on update. The only difference when you're applying it at the device level and at the container level is that at the device level, it is specific to that device itself. Whereas at the container level, it will get applied to all the children of those containers. So for example, if I apply it at DC1 leaves, it will get applied at Arista 1, Arista 2, and VTEP 2. Whereas if I were to apply it at DC1 leaf 1, it will only get inherited by Arista 1 and Arista 2. For the purpose of this demo, we are sticking to applying at the device level. We'll see a container level assignment in demo number 2. So we'll go ahead and click on update. So now you can see there is a green highlight around DC1 spine switch, which shows there is a pending action against it. We'll just go ahead and click on preview. You can see the action is against the device spine, and it is an image bundle assignment. So we'll go ahead and click on save. And you can see now a task has been generated, which is nothing but a work order that CVP has created. Now there is another message that we are seeing out here. It says image and extensions are out of sync. So this is basically CloudVision's compliance check automatically kicking in and telling us that, hey, the image bundle mapping on the CVP is different from what the device is running. So in case if you have an image bundle that is assigned to your device on CloudVision, which is different from what the device is running, maybe somebody upgraded it from the CLI. So CVP will tell you if there is a mismatch. Now, once we execute this task, this warning would go away. So we can see our task has been created. It's for spine device created by CVP admin and upgrade image task currently in pending state. If you click on the device ID, that is number 46, you can see more details about the task, like who created it, when it was created, and what is the change that is going to be done. So you can see we have 425.9m and Terminator 119.5. A reboot will be done. And the current running software image version is 425.3m and Terminator is 119.4. So to execute this task, what we'll do is we'll select the task, and in CloudVision, every task has to be executed as part of a change control. So even if you have a single task, in order to execute it, you have to put it as part of a change control. So let's go ahead and do that. We'll click on create change control, and you can see a page has opened allowing us to select an arrangement. So if you have multiple tasks, you can run them in parallel. Right now, since we have only one task, we can only run it in series, but we'll take a look at a parallel execution and execution using templates in demo number 2. So for this demo, we'll just stick to series execution. We'll go to change control, and you can see our change control has been created. You have a change control ID which is generated. You can change that to a unique ID. Current status is pending approval because right now I have not reviewed and approved this change control. This is a very good feature in CloudVision, wherein you have the same level of AAA control, role-based access control, wherein certain users can be denied the ability to review and approve. And only certain users can execute a task. So let's say if I have my colleague who has only the ability or permissions to create a task, can create it, but cannot execute it. Only I have the permissions to do it, so I can push that change down to the device. Now, another good feature is the scheduled for. So what change control allows you to do is schedule the execution of the change control. So let's say I created this task today, but I want to run the upgrade or push down the configuration at a specified date, maybe during a weekend when the traffic is low. So I can schedule the change control, and CVP will note the time, and whenever the time comes, it will execute it. I also have the auditing capabilities where I can see which user made the change and when it was made, and also what all devices will be affected as part of this change control. So I have the visibility of what all devices in my network are going to be affected when I run this change control. Now with that clarified, let's go ahead and take a look at the change control hierarchy itself. So I have the root, which houses my upgrade image task. So right now there is only one task under that. So similar to what we had done on the CLI, we'll go ahead and create certain stages under this, wherein we will add our pre-checks and post-checks. Now in order to do that, we'll just select on the root stage, and we'll go ahead and click on add child stage. So you can see a sub stage has been created. I have the ability to rename it. So I'll just rename it so it is more intuitive to me. I'll do a pre-upgrade checks. And you can see a pre-upgrade check stage has been added. Similarly, I'll also add a post-upgrade check, wherein I'll put my post-upgrade checks into the change control. All right. Now, I can also reorder these stages. So I do want to run the pre-checks before the post-checks. So I'll put it before the upgrade image starts itself. I also have the ability to run these stages in series or parallel. So I can select parallel, and what that will do is it will execute all these stages in parallel. However, in this case, we want to run the pre-checks before the upgrade and post-checks after the upgrade. So we'll go with the series execution. All right. Now, in the pre-checks, similar to what Deborah had showed you using show commands on the CLI, we'll use something called as snapshots first. So we'll just take a look at what is snapshot. So snapshot is, as we had discussed before, you can configure certain show commands on CVP that will be executed on the switch as part of the change control execution. Now, snapshot is very simple. You can create a very basic snapshot called as a version snapshot, wherein you can just provide a show command called as show version and select what all devices that you want to run it against. It can be any number of devices that are currently on your CVP instance. You can also specify interval that you want to run it against. The minimum has to be 5 minutes, but it can go up to days or months. So for the purpose of this demo, I have already created 2 basic snapshots. One is a configuration snapshot, which audits my running config and the startup config. I run it on all the Arista devices that I have on CVP, and it runs at a 5-minute interval. I also have a mlag and VXLAN config sanity snapshot, which runs the show mlag VXLAN config sanity and show mlag config sanity on my Leafs devices. So I'll go ahead and use this configuration snapshot in my change control. All right, so I'll open the change control. I'll select my pre-upgrade check stage. I'll go on add actions. And from here in the dropdown, I can select the snapshots that I have created. So I want to add the configuration snapshot. I can click on that and select what all devices do I want to run it against. There is no limitation on how many devices you can run it against. For this specific change control, I only want to run it against the spine device. So I only select the spine device. And now you can see my configuration snapshot has been added to the pre-upgrade checks. Let's do the similar thing on the post-upgrade checks. So we'll select the dropdown, head down over to the configuration snapshot, select my spine device, and it is added. All right, so one example we had seen during using the snapshots. Now let's take a look at how we can add certain actions to the pre-upgrade checks and post-upgrade checks. So for that, we'll head over to the Actions tab, wherein you can see we have a list of custom actions, which is basically user-defined actions that you can create. These are very basic Python scripts using which you can create that. We also have certain built-in actions that are inbuilt in Cloud Vision. So if you're performing in, let's say, an MLAG upgrade or ISSU upgrade, you can use the check MLAG health. Or if you're planning to gracefully pull the device out of BGP and put it back in after the upgrade, you can use enter and exit BGP maintenance mode as part of your built-in actions in the change control. Or you can also have a CLI snapshot. So you can just specify a show command that you can capture as part of your change control process. Now, custom actions, we have a list of custom actions that are available out here. We are going to be using the TAC bundle. So this is a very basic example of a custom action that one of our team members had created, and it is again available on our public GitHub repository that you can also use in your Cloud Vision instances. So basically, it just collects the support bundle on the devices, which you can add before and after a task that you are performing, which is usually very helpful in case you're troubleshooting something and you need a data point of what was the switch state before and after a change. So we'll go ahead and add this TAC bundle to our change control. So we'll head over to the change control tab. We'll go over to our change control stage, and we'll add it to both the pre-checks and the post-checks. Now, instead of adding it individually that we had done last time, you can select both of these stages and then add that particular action which you want to add. So in this case, we are adding the TAC bundle action. And you can see it gets added to both the pre and post-check upgrade stages at the same time. So that is a very also helpful feature in change control, where you can add multiple actions to multiple stages by selecting them at the same time. Now, before we head into the another action that we want to add, we'll quickly check the network topology. So on the topology page, we can see the actual physical topology that is detected using LLDP. So you can see I have my spine device, wherein Ethernet 1 of spine goes to Ethernet 1/1 on Arista 1, and 2/1 goes to Arista 2. And similarly, I have 3/1 going to VTEP 2. Now, what I want to do is I want to ensure before I trigger the upgrade and after the upgrade, these links are up. So before and after the upgrade, these links should be up. How I can do that is, again, using a very basic custom action using check interface status. So it is a very basic action. It simply takes in a list of interfaces and ensures whether the interface status is connected or not. So I'll head back over to my change control, select my pre-check and post-check. And from the dropdown, I'll go ahead and add the check interface status option. So here I can provide Ethernet 1/1, Ethernet 2/1, and Ethernet 3/1 that we just saw on the topology page were my links which were going to all my leaf devices. So these are the interfaces that I want to check on the spine device. So in this case, I'll only select the spine switch, and I'll just verify the interface names are correct. They look to be correct, and I'll just go ahead and add to change control. So now you can see all the pre-checks and the post-checks have been added. What I can also do is, in order to save some time, I can run the pre-upgrade checks in parallel. So I can select that stage, go on to the drop-down of series and make it parallel. So you can see now the color coding has changed, wherein now the pre-checks will be executed in parallel. So all of them will be fired off in parallel. Now, as part of the post-upgrade checks, what I want to do is, since after an upgrade, there can be a brief amount of time before the front panel interfaces come up. So I want to give a grace period before I fire off my post-upgrade checks. So that I can do again using a very basic action using sleep, wherein I just specify the number of seconds where the change control will wait before it triggers my post-upgrade checks. So that's allowing a breather time. Maybe you have an MLAG reload delay that is configured, or if your front panel interfaces can take some time, that allows a breather period for you to before your post-upgrade checks kicks in. I can also select these changes and I can group them under a substage, which will again execute it in parallel. So now that my change control is prepped, I have my pre-upgrade checks ready, which will be executed in parallel. I have my upgrade image task, which is going to be executed after the pre-upgrade checks, following with the post-upgrade checks, giving a breather room for the front panel interfaces to come up. And then I'll trigger my post-upgrade checks, which will again be executed in parallel. So now I can go ahead and select review and approve. Again, CloudVision allows you to review the changes before you go ahead and execute those changes. So again, I can re-verify whatever I want to do before I go ahead and make those changes. All right, so I'll go ahead and click on approve. You can see the status has now been changed to approved. The approver was CVP admin. So again, the role-based access control applies here as well. So you can have a AAA server, maybe a Radius or a TAC server, which controls your role-based access control, ensuring certain users are not allowed to approve or even execute change controls. So I'll go ahead and click on execute, and you can see all my pre-checks have fired off. Now, for the purpose of saving a bit of time, what I've done is I've fast-forwarded the upgrade, because an upgrade process can take a bit of time. So you can see the video has been fast-forwarded a bit. All right, so my upgrade image task has been completed successfully, followed with my post-upgrade checks, which we have kicked in, and that has also completed successfully. So another good feature that comes as part of built-in change control itself is the logs. So CVP logs each and every stage that it is doing. That includes checking what images are present on the flash, maybe cleaning up the flash with old EOS images, which are not part of the image bundle, ensuring downloading the EOS image from the CloudVision image repository. All these stages are logged into change control. Now, this is very helpful in case if you have an issue where the change control failed and you're trying to troubleshoot where it failed. So you can go ahead and download those logs and send to TAC even for troubleshooting. So now we can go ahead and check our device. We can see it is upgraded to 425.9M and the streaming agent is 119.5. So with that, we conclude our demo number 1, where we upgraded the EOS image by manually creating the image bundle and also creating our entire change control stage. Now, I have a very quick demo. The second one is not going to take a lot of time. In this one, I just want to showcase how you can upgrade or install an extension on the switch without even touching the EOS image. So if you don't want to reboot the device, and also to showcase how you can make a template of these pre-checks and post-checks. So maybe if you are doing upgrades frequently, or if you want to make sure that you don't waste a lot of time building these change controls, you can create these templates, which you can utilize later on. So let's go ahead and take a look at that. In this demo, we'll be focusing on Arista 1 and Arista 2 devices. So I have the streaming agent version 119.4. I'll upgrade it to 119.5, similar to the spine device. So we'll head over to the network provisioning page. Here we can see our Arista 1 and Arista 2 are part of DC1 Leaf 1 container. So in this case, I've already done an image bundle mapping on the container level. So you can see there is a very small container icon next to the image name, which means that image was inherited from a parent container. If we compare that to the spine device that we just upgraded, you can see there is a no container icon, which means it was directly assigned to the device. So here we can see the image bundle is applied at the container level. You can see the same information from the image repository page. So we'll head over to the image repository, select the image bundle. So 427.4, 119.4. We'll click on applied containers, and you can see it is applied at DC1 leaf 1, which gets inherited by Arista 1 and Arista 2. Now, at this stage, what I can do is I can either go ahead and update this image bundle. I can remove the Terminator 119.4 and put in the 119.5, or I can create a new image bundle and then put the same EOS release in that and the newer version of Terminator. The only difference between these two actions would be in case if I'm updating an existing image bundle, this means that all that change will be propagated to all the devices where that image bundle is assigned to. Now, since in this case, my image bundle is only assigned to Arista 1 and Arista 2, the scope is only limited to these two devices. Whereas if I were to apply to a lot of devices and I only want to upgrade it on 2 devices, it is better to go ahead and create a new image bundle. The only thing that you have to note is that the EOS image version has to be the same. So if you don't want to change the EOS image version, make sure to have the same EOS.swy file, which is present on the switch that is currently running on the switch in the image bundle itself. So in this demo, we'll just go ahead and update the existing image bundle itself. So we'll remove this Terminator. We'll click on yes, and you can see that Terminator version is gone. From the image repository, since in demo 1, we had already uploaded it, we have this 119.5 in the CVP image repository. We'll select that, click on add, and you can see it gets added here. We'll update the image bundle name to reflect the change that we have made, and we'll click on save. Now you can see CVP tells us that, hey, this change is going to be applied on 2 devices. Are you sure you want to do that? We'll go ahead and click on yes. And if you head back over to the network provisioning page, you can see a task has been created for both Arista 1 and Arista 2. Now, since in this case, you can see the CVP compliance check has already kicked in. It is telling you that the Terminator version mismatch is there between what is running on the switch and what is mapped on CVP. So again, this warning will go away once we execute these 2 tasks. So now you can see we have 2 tasks with us. We have a task for Arista 1, a task for Arista 2. If you click on the task itself, we can see more details about the task. Again, the design software image, we can see the EOS version is the same. This means the EOS version is not going to be changed. In that case, the reboot will not be done. Only the Terminator version is different, which is going to be upgraded. Same we can see for Arista 2 switch as well. You can see the changes are consistent, EOS 427.4, only the Terminator version is different. Now, in order to execute these 2 tasks, we can select both of them at the same time and add it to the change control. And in this case, now you can see I have the parallel option available as an arrangement because I have 2 tasks which I can execute in parallel. So we'll go ahead and do that. We'll select the parallel option and click on create change control. So you can see my change control has been created. I have the 2 tasks under the root, Arista 1 and Arista 2, which are there under the root of the change control. Now, as we had done in demo number 1, I can go ahead and add a configuration snapshot again, or an MLAG VXLAN config sanity snapshot, or I can go ahead and add any actions that I want to add. It could be a check interface status action, or could be a TAC bundle action. But the process is going to be repetitive in the sense that I will have to do that again for both of the devices in the change control itself. So is there a way where I can maybe create a template which I can reuse every time I'm performing a standard upgrade? So that can be done using something called as change control template. For that, we would have to create an action bundle. So let's take a look at what action bundles mean. Now, this is a very basic concept. You just have few actions that you can bundle together into an action bundle. So I have created a pre-check action bundle, which houses my check interface status action. You can provide a list of interfaces here, or you can provide a list of interfaces in the change control itself based on what device you are checking it against. You can also provide a configuration snapshot. It could be a MLAG VXLAN config sanity snapshot or any snapshot that you want to create. Similarly, I have a post-upgrade checks wherein I have the check interface status. Now, just to relate what these interfaces are, we'll head over to the topology page again. Let's go ahead and see the Arista 1 and Arista 2 devices. So you can see the Arista 1 device has an uplink going to spine device, which is Ethernet 1/1. And similarly, the Arista 2 device has an uplink going to spine device, which is Ethernet 1/1 going to 2/1. In addition to that, these 2 devices are also have a link between these 2 of them. So you have 33/1 and 34/1. So I want to make sure all these interfaces are up before and after the upgrade. So These are the interface lists that I'm going to provide into the action as part of the pre and post upgrade checks. I also have a task bundle wherein I'll group the tasks together, which are going to be executed. Now, I have created my action bundles, basically a pre-upgrade bundle, post-upgrade bundle, and a task bundle. Now I can use these bundles into a template. So let's see what a template actually looks like. So for an example, I have already created a standard upgrade template here, wherein I will do the exact same thing which we had done in demo number 1. We will create these 3 different stages. Instead of manually creating them every time, I can create it in one go. I can again select the stages to be in series or parallel. But since I want to perform the upgrades, pre-upgrade before the execute task, I'll put them in series. I can select the action bundle which I want to. I can select which all devices I want to run that particular pre-upgrade check against. And I can also specify if I want to arrange the bundles for that stage in series or parallel. So in this case, I want them in parallel. I have the task stage wherein the tasks will fit in. Again, it could be series or parallel. And finally, I have my post-upgrade checks, which I'm going to run as part of the last stage, which I can again specify to be run in series or parallel. I want to run them in parallel for any n number of devices that are there. There is also an option of specifying a regular expression, which you can specify to what all devices should come under the scope of that. In this case, we'll go with whatever devices are in there in the change control. So now that my template has created, let's head back over to the change control and we'll click on the change control itself. We'll select our root. And then from the select a template dropdown, we'll select the template that we had already created, which was the standard upgrade template. We'll click on apply. And now you can see my entire change control has been populated with the pre-upgrade checks, which is for Arista 2 and Arista 1 as part of which is going to be executed in parallel for both of the devices. And the individual actions inside them are going to be executed in series, meaning the check interface status is going to fire off at the same time for both of the devices. Similarly, I have my execute tasks, which are going to be executed in parallel. This means terminator is going to be upgraded at the same time for both of the switches. And lastly, I have my post-upgrade checks, which houses my, again, post-upgrade actions, which I can run. I can click on review and approve. I have another stage of approval or review where I can check, okay, what I'm doing is correct. I can select it for all the devices which are part of the change control. Once all that is validated, I'll click on approve and I can say my status is now approved. The approver was CVP admin, and now the change control is staged for execution. We'll confirm that, okay, go ahead and execute it. And you can see my change control pre-upgrade checks have fired off immediately. And we are into the upgrade image stage wherein CloudVision is checking the terminator version on the switch, and it is 119.4, and it is going to upgrade it to 119.5 by removing the older extension and installing the new one. Now, once that is completed, it'll take just a few seconds, and we will start with our post-upgrade checks. You can see the post-upgrade check stage has completed, and the entire change control stage is now complete. We'll head back over to the devices page, wherein using the real-time telemetry information, we can confirm the agent version is actually upgraded to 119.5 for both of the devices. If we click on the device itself, you also have a nice option of seeing a graph where you can see at what point in time it was an older version and what point in time it was a newer version. So you can see that for Arista 2 as well. Click on the streaming agent version and you can see there is a nice graph telling you what was the version before and after. All right, folks, so that was for demo number 2. Let's just quickly wrap up on the post-upgrade checks. So we did see example of post-upgrade checks, again, using snapshots and action bundles that we saw. We created an action bundle and grouped multiple actions against that action bundle and used them in a template. In addition to that, we have seen sometimes where customers like to compare the switch state, that mean including the what are the IPv4 routes that were present on the switch, or maybe the ARP entries that were learned on the switch, or the MAC address table count that was there on the switch before and after an upgrade, or maybe before and after a configuration was pushed on the device. Now that is very easy with CloudVision because CloudVision relies on the real-time telemetry information that is getting streamed from the device to CloudVision. Now using that information, you can create an aggregated table or a dashboard where you can group multiple devices and compare their metrics at the same time. And all this information is real-time, so you can go back in time and see what was the table entries maybe before an upgrade or maybe an after an upgrade. So this way it allows you to do a very nice comparison of overall state of the switch, including whatever ARP table or IPv4 route count or MAC addresses that you want to compare. So these custom dashboards, there are certain built-in dashboards that are available. You can create your own custom dashboards using metrics that are available on Cloud Vision portal. All right. So we have already shared some of the links that are part of this slide. So you can always go log into our Community Central. So on Arista Community Central, we have a lot of very good articles that are written that provide you more information about creating these change control templates, or maybe using custom dashboards to monitor your device metrics in real time. And you can go through these articles, which will give you a very good overview of what we have talked about in this webinar today. With that, I think we'll take any questions that are pending, and I think I'll hand it over back to Divya.
Well, hey guys, this is Devroy. I did want to correct one thing I said. Our lab images, especially VEOS, do have layer 3 feature sets. Now they're limited compared to the actual production software, especially our containerized lab version, but they still have some layer 3 features and can be useful and fun for testing. I'll update the slides to reflect that. So when you receive this in the future, you'll have the correct information there. All right, sorry about that, Divya, go ahead.
No problem, thank you. And I want to, again, we're about to wrap this up, but I see a couple of questions. So we're going to keep the session running for another 5-10 minutes, so that if you have any questions, please go ahead and post it. We'll make sure we're taking care of it. In the meantime, I want to say thank you for everybody staying back here. The next session is lined up for November 16th. Mark your calendars, and our next presenter is actually here. So Jonathan, if you just want to give the audience here a quick intro into what you're going to be talking about, because it is tied to upgrades as well, that would be great.
Hey, Divya. Yeah, always happy to. So we talked about it, or maybe alluded to some of the things we'll be discussing in the next webinar throughout today's presentation. I mean, reloads is just such a monumental thing to discuss, and it's hard to fit everything in one, even we're already over the 1 hour period, right? So we'll be going further into MLAG reloads, especially in like different corner cases and concerns that you should at least be concerns that you might have before reloading a device. So how do you maximize that network uptime or minimize your downtime, however you want to look at it. In addition to MLAG, we'll be looking at chassis, ideally MLAG with chassis. I'm also hoping to talk a little bit about things like BGP maintenance mode. And so how can you offload traffic from devices in preparation for an upcoming maintenance window, things like that. It's still a little fuzzy because I need to figure out exactly how long it's going to take to talk about all this. But there's a lot of fun stuff, and that's at least a high level overview of the different topics that'll be in webinar 3.
Thank you. And if y'all have any questions, any feedback, we'd love to hear from you. Please hit us up at tac-webinar@arista.com. Your feedback and your participation is what is going to dictate the series for 2023 and how things shape up. So we definitely want to hear from you. Again, as we mentioned earlier, this is recorded, so we will have this posted on our Arista Community Central. It's on our YouTube channel, and so if you want to go back and view, or you want to share it with others, it's available as well. And if you do need to get in touch with us at Arista TAC, it's easy. We can be reached at support@arista if you have any production network related or product related questions. You can hit us up there. With that, I'd like to say thank you, and we hope to see you again November 16th. In the meantime, we have a couple of questions. The session will be open until we answer the questions, and then we'll close it out. Thanks, folks. Again, for the Arista panelists, if you guys want to make sure that we are taking care of the questions, once that's done, we'll close. Thanks. I'm going to take this opportunity to answer a question that I see posted there about whether the slides will be available. The answer is yes. So when you go to the Arista Community Central page, you will have the recording as well as the slides. So it will be made available, and we will also send out an email to all of the email addresses that we have for the list of registrants once the video and slides are up and loaded. Actually, if any of our panelists want to answer some of the questions, I know we still have a few open questions that are streaming in. If you want to take this opportunity to answer it over audio instead of typing, audio is all yours. Let me know.
See, there is a question about an action bundle to check interface status of all the interfaces instead of manually specifying them. So that is something definitely that can be done. So it's just a simple Python script. You can look into the CVP database using the CVP APIs, find out what all interfaces are there for that particular device as part of your change control, and then populate that interface list into your custom action that you're building. Again, we have very good examples which are there on our GitHub repository, public GitHub repo that is linked in the slide. You can take a look at them to understand and get bootstrapped or understand how change control actions are built, get the basics clear, and then you can go ahead and create your own custom actions based on your customized needs for your environment. I hope that answers the question.
Okay, I think we're going to go ahead and wrap it up. Thank you, everyone, and we'll see you next time. Thanks. Bye.
The one that we found on here, small thing, was the EOS.